Welcome to the next video of fuzzy analysis. In this lecture, we discuss about fuzzy number. Fuzzy number. What is fuzzy number? What is fuzzy number? We can express the fuzzy number as a fuzzy set defining a fuzzy interval in real number, or we will define the fuzzy number in real number, and fuzzy number is a fuzzy set. It is a fuzzy set, which means that the membership function of any number x must belong to 0 and 1. The fuzzy number is a fuzzy set, and we uh, represent the fuzzy number in real line, like we have any real line and real line interval, which is 4 and 5. We can express the fuzzy number along y-axis, which is mu a of x, and its highest membership value is 1. Any number between 4 and 5 in real interval 4 and 5, its membership function must lie between 1 and 0 and 1. Let if any number which is less than 4, which does not belong to the interval, its membership value is 0, and any number which is greater than 4 and does not belong to interval, its membership value is also 0. Any number which belong to between 4 and 5, its membership function must be between 0 and 1, like any number 4.1. In real number, its membership function lie in 0, line 0 and 1, which is 0.3, or any number which is 4.6. Its membership function is 0.4. We can say that the membership function of fuzzy number must be lie between 0 and 1, but the membership function of Cripps value is only 0 and 1. If the for the interval 4 and 5, the Cripps membership function is 1, but the fuzzy it is not 1. It is between 0 and 1, any value. Now we will discuss how we deal with fuzzy numbers. We see that in fuzzy number, the boundary of interval is ambiguous, which means unclear. The boundary of interval, the interval 4 and 5, between this interval, the values between this interval are unclear, ambiguous, which is not clear. We are not 100% sure. Maybe this is totally belong to the interval or partially belong to the interval. And we represent the fuzzy interval by two endpoints, which is A1 and A3. This is fuzzy interval. The fuzzy interval have two endpoints, A1 and A3, and at least one peak point, A2. Must be one peak point. Maybe different peak point, A2 dash, it has different peak point, but must be one peak point. This means that the membership function at mu a of a2 must be 1 in the p point. Like in the interval 4 and 5, we have any p point 4.5. In this p point, the membership function must be 1. And other points, it is not necessary to be 1. So we define the fuzzy number. What is fuzzy number? Fuzzy number. What is fuzzy number? It is a fuzzy set. Fuzzy number is also a fuzzy set. The following condition must satisfy. If all of these conditions are satisfied, we call this is fuzzy number. If one of the condition is not satisfied, this is not a fuzzy number, and we cannot discuss this further. Like first of all, the fuzzy number must be convex fuzzy set. Fuzzy set. It is necessary to be a convex fuzzy set. What is convex fuzzy set? In a classical set, we call a space is called convex. Let we have any space x in classical theory, we call the space is convex if we take any point x1 and x2, and I take a line between x1 and x2. The point between the line x1 and 2 must belong to the space. This is convex space, and I take another space which is y, and I take a point x1, another point x2 in the space, and I take a line between x1 and x2. At some point does not belong to the set. So this is not convex. Or in real line, we call a set is convex if I take a graph, any graph, and I take 2 point x1 and x2 and draw a line between x1 and x2, hold the graph must lie below the line. This is called the convex in real line. But what is fuzzy convex? What is convex set? Convex fuzzy set. Uh, we says a set is convex if I take a point mu a of t is equal or greater than minimum of mu a of r and mu a of s, where t is equal to lambda r plus 1 minus lambda of s, and r and s belong to rn, and lambda belong to 0, 1. We says the I draw this graphically. How we show this graphically? Any set is convex. Like I take a point, I have a graph, and I take some point. This is point R, and this is point S. The point R has membership function mu A of R, and the point S is corresponding membership function mu A of S. And if I take any point between R and S, if I take any point T, the membership function corresponding to T is mu A of T. If the membership function of T mu A of T is greater than minimum of mu A of R and mu A of S, then we says that the graph is convex or the function is convex. In the graph, it is clear that in the point R and S, if I take any point between R and S, which is called T, whenever I take the point here or here, the membership function corresponding to any point between R and S must be less than minimum of a membership function of R and S. This is called convex. This is convex fuzzy set. Convex fuzzy set. I give an example of non-convex fuzzy set. Like I have a graph, like this is a graph, and I take a point between, I take a point, this is point R, and I take another point, this is point S. The membership function corresponding to R is mu A of R, and the membership function corresponding to S, so this is point S, mu A of S, and I take any point between R and S. I take this point as a T, and the membership function corresponding to T is mu A of T. From the graph, it is clear that the mu A of T is not equal or greater than minimum of mu A of R and mu A of S. So we say that the graph is, the function is not convex. Here we clear the concept of convex. Now we will continue the definition of fuzzy number and fuzzy convex. The first condition of fuzzy number is it is convex. Convex fuzzy set. The fuzzy number must be convex fuzzy set. The second definition is normalized. Normalized fuzzy set. The normalized means if I have a fuzzy number A1 and A3, this is fuzzy number, and there is a peak point between A1 and A3 is A1, A2, then the membership function of mu A of A2 must be 1. The membership function of peak point must be 1. If the membership function of peak point is 1, we says that this is normalized fuzzy set. Otherwise, it is not a normalized fuzzy set. And the third condition is its membership function is piecewise continuous. It must be piecewise continuous because I define the interval in Cripps value, which is A is equal to a1 and a3. Here the membership function which is less than a1 is 0, and which is greater than a1 is also 0, and between a1 and a3 is 1. So we define piecewise with membership function here, and but the membership function of a1 and a3 must lie between uh, 0 and 1, and we define this as a piecewise continuous function, e.g. the membership function of any number x is 0 if it is x is less than a1, and it is between 0 and 1 if x belong to a1 and a3, and it is its membership function is 0 if x is equal or greater than a3. So we define the membership function of fuzzy number as a piecewise continuous function. And fourth property is that it is defined in real number. If I have a function f of x is equal to 1 upon x, and I take interval -2 and 2, but between -2 and 2 the point is 0, and the function 1 upon x not defined at x is equal to 0, and at x is equal to 0 f of x is equal to 1 upon x is not defined. So the fuzzy number must be defined in real number. If these four properties satisfy, we call the number is fuzzy number. I take some examples of fuzzy number, which is if I have a function f of x is equal to 1 divided by 1 plus x square, and the domain is real number, x belongs to R. If we have domain real number, it is fuzzy number. How? Let I take a graph of this. This is real number R. This is the membership function. This is 1 mu a of x. If I take 1, x is equal to 1, the f of x is equal to mu a of x is equal to 1. It is 1 at 1. And if I take it is if x is equal to 0, 1 upon 1 upon 1 plus x square is 1. If x is equal to 1, it is 1 upon 2. X is equal to 1. If x is equal to 2, its value is 1 upon 5. If x is equal to 3, its value is 1 upon 10. And the graph of 1 upon 1 plus x square is look like this. And if x is equal to -1, it is also 1 upon 2. And this is the graph of the function 1 divided by 1 upon x square. You will see that first of all, it is a fuzzy number because it is a convex fuzzy set. Whenever you take any point R and any point S, its membership function is mu R and its membership function is mu of S, and any point between R and S, you will take any point T between R and S, its membership function is mu A of T, which is greater than minimum of mu R and mu S. It is convex. Second, we see that it is normalized because at x is equal to 0, the membership function of x is equal to 1. At p point, its membership function is 1. So it is normalized and it is piecewise continuous function. This is continuous and also piecewise a continuous function, and it is defined in whole real number or -infinity to +infinity. It is defined. And I take another example of fuzzy number mu a of x is equal to 1 divided by 1 plus x square. x square whole square. If I put x is equal to 0, it is again 1. And if you draw this graphically, it is also a fuzzy number. Now, in next video, we will discuss some other fuzzy number and how we convert any interval to the fuzzy number. If a function, these are the functions which are already fuzzy number and fuzzy valued function. Some function which are not fuzzy number, like f of x is equal to x, or f of x is equal to x square in the domain of R. It is not a fuzzy number because its range is minus infinity to plus infinity. But in fuzzy number, its range must be 0 and 1. How we convert any functions to fuzzy number, we will discuss in next video. How will we convert fuzzy number to any functions to fuzzy number? Thank you.